At this point, I and Miss Tenorio will be discussing about shapers. So do you have any idea what a shaper is? Well then, if none, here's what a shaper is. A shaper is used as a reciprocating cutting tool that has flat and curved surfaces, keyways, slots, and irregular shapes. This may be slow, but it is reliable and having satisfactory results. These are still used in some industries, but are not as common given the rise of CNC machines.
Similar to any other machine, shaper machines vary on types. These include the crank type shaper machine, geared type shaper machine, and hydraulic shaper machine. Crank type shapers are used to hold workpieces on the table. Geared type shapers has a ram that is reciprocating. This is vital as it affected by reciprocating motion by the rack, pinion, and rack tit. Lastly, a hydraulic shaper machine utilizes the hydraulic mechanism to drive the ram, giving cutting speed and force. These are quite to use yet reliable ones.
Before operating a shaper, an operator must be fully knowledgeable of its parts. Listed are the parts of a shaper. The base supports the weight of the machine and absorbs the cutting forces. The column contains the drive mechanism and supports the ram and table. The cross rail holds the saddle and table for lateral movement. The table holds the workpiece. This can be rotated and change levels. The ram carries the tool head, while the tool head holds the cutting tool and functions for any direction of relief movement.
There are also different shaper machine operations. These operations control various surfaces like horizontal, vertical, angular, and irregular surfaces. Machining horizontal surfaces create flat and leveled surfaces that are held in a vise. To perform horizontal machining on a shaper, first clamp the workpiece to the machine table or vise. Second, position the tool at an optimal inclination and height above the workpiece. Third, calibrate the depth of cut and set the machine in motion. Fourth, adjust the strokes position so that the tool advances 12 to 15 mm before commencing the shaping process. Fifth, engage power feed once cutting commences. Sixth, inspect the workpiece and repeat the procedure if further material removal is necessary. Seventh, secure the tool vertically with the cutting edge slightly away from the workpiece to avoid digging in. Eighth, avoid excessive projection of the cutting edge below the tool holder. Lastly, do not extend the vertical slide of the tool head too far below the ram to avoid compromising tool integrity and chatter. For additional tips, use a sharp tool with the correct rake angle for the material being machined. Use a coolant to lubricate the tool and workpiece and reduce friction. Take light cuts to avoid overheating the tool and workpiece. Monitor the machining process closely and make adjustments as needed. Machining vertical surfaces are for removal of materials from a workpiece by reciprocating cutting tools up and down and create vertical surfaces as well. Steps: first, align and secure workpiece. Second, select and mount side cutting tool. Third, adjust length and stroke position. Fourth, set vertical slide to 0 position. Fifth, engage down feed screw and apply 0.25 mm feed at the end of each return stroke. Sixth, repeat step 5 and 4 for roughing and finishing cuts.
Angular machining is for the tool head to achieve a desired angle. It is done by adjusting the apron to minimize the tool from interfering with the workpieces. A universal shaper may also be used to perform this process. For irregular surfaces like concave, convex, and blended shapes, a round nose cutting tool is used.
In addition, there are also cutting slots and keyways to be used on a shaper. Machining of external keyways. First, use a square nose tool similar to a parting tool. Second, drill a hole at the blind end of the keyway, slightly larger in diameter than the keyway. Third, adjust the stroke so that it ends precisely at the clearance hole. Fourth, reduce the cutting speed. Machining internal keyways. First, hold the tool on a special tool holder so the tool post will not hit the work at the end of the stroke. Second, lock the clapper block in the clapper box to prevent the tool from lifting during the return stroke. Third, lubricate the work to prevent tool wear.
It is important to take note that there are several shaper machine mechanisms. Rotational motion can be transformed back and forth that is given to the ram. In most shaper, a quick return mechanism is present. For this quick return mechanism, there are various methods: crank and slotted link mechanism, Whitworth quick mechanism, hydraulic shaper mechanism, automatic table feeding mechanism. Crank and slotted link mechanism is used to convert rotational motion to linear motion, involving crankshaft and slotted link. This is done as the rotation of crankshaft moves the link back and forth, affecting the ram to be in linear motion.
The Whitworth quick return mechanism is used to achieve reciprocating motion. The links allow the ram to move on various speeds and strokes, obtaining a faster return motion.
For hydraulic shaper machines, the piston is driven by a hydraulic pump to move the ram forward and backward. This works like any hydraulic mechanism.
Last mechanism is the automatic table feeding mechanism. This uses a ratchet wheel to feed the table during cutting operations. It is fixed to a screw linked to the table. It turns in sync, driving the table in retraction for accurate and correct machining.